Hello. There we go. So everyone's here on like the week before Christmas, listening to Microservices. Right. So my name is Sandeep. Thanks, Kelly, for the introduction. You are at the Google Developer Launchpad space. If you have a meetup that you want to run here, come talk to me. If you want to talk at SF Microservices, which I highly recommend, come talk to her. We are looking for speakers, right?
Yeah, always looking for speakers, anytime.
Yep. So I'm a developer advocate / software engineer / whatever you want to call me at Google Cloud. I work on the cloud. I make it fluffy. And today I want to talk about gRPC versus REST. So in this crowd, I expect a lot of hands, but who's heard of gRPC? Yeah. Who's using gRPC? See, that's interesting. Only one person.
Yeah.
Half.
No, I have in the past.
You have in the past, okay. So a lot of people are using it, right? Including Google and Cisco and Lyft and blah, blah, blah. You see this on the gRPC website. But the talk I had titled was gRPC versus REST, and a lot of people are probably like, you are wrong, you can't compare those two things. You'd be right, you can't really compare gRPC versus REST with a clickbait title to make you come and see my talk. gRPC has a bunch of stuff that a REST API doesn't call: cancellation, bi-directional streaming, client-server generation for the most part. REST has a tons of stuff that gRPC doesn't have: hypermedia, HTTP verbs, get, post, acting on resources, the whole point of REST, right? But the one thing they do share is you can hack both to do remote procedural calls. And gRPC is built for that, and you can use a REST API to do that. In fact, if you're using a REST API just to do RPC calls, which a lot of people do, you're in the swamp of Pox, but it's just Martin Fowler, what does he know? You should probably be using a lot more if you want a real REST API. But from practice, I've seen a lot of people say they have a REST API and all they're doing is sending JSON over HTTP1 and calling a remote function. That's just an RPC, and it's fine. You don't have to do more complicated stuff, but just know what you're doing. So for the rest of this talk, rest of this talk, right? REST really equals like a JSON RPC, and it's just I'm not using any sort of framework. I'm just doing a normal JSON over HTTP1, but it's basically JSON RPC. So if you look at the comparison between these two formats, and what I wanted to do is, I don't work on the gRPC team, but I work very closely with them, and every day they tell me gRPC is the best thing ever. I'm like, okay, but do I believe them? So I wanted to convince myself that it actually was better, and not just them telling me every day that it's better. So gRPC is basically Protobuf version 3 over HTTP2 post. REST or JSON RPC is basically JSON over HTTP 1.1. And you can argue with me over, you can do XML over HTTP2. Yeah, okay, whatever. Everyone's doing this. So what we're really comparing is JSON versus Protobuf, right? Serialization format, and then HTTP1 versus HTTP2. And the story looks pretty interesting for both. So it's plain text versus binary, human readable versus machine readable, repetitive versus compressed, and something I'm not 100% sure, so I want to test it. Faster deserialization versus faster deserialization. But the big thing, of course, is everything supports JSON. Every single programming language I can think of, every single data exchange form, everything supports JSON. Protobuf has much more limited support. Very, very, very similar story for HTTP1 versus 2, plain text versus binary, no pipelining versus native pipelining. It's a new connection per request versus a persistent TCP connection. Repetitive versus compressed, polling versus streaming. You got to use TLS with HTTP2 unless you turn it off, which you shouldn't do. And again, everything supports HTTP1, much more limited support for HTTP2. Growing quickly, but still much more limited. But just looking at those, you're like, oh, obviously gRPC is going to be better. But again, I wanted to actually do this myself. So I said, let's benchmark. And I have no idea what I'm doing because I'm not a benchmarking person. But you know what? It's okay. Just like this dog, I'm going to try. So I did two things. One, I ran a client and a server, one in our Oregon data center and one in our South Carolina data center. And then I ran the same client and server in the same zone, right? So I said, does having that cross-country network latency really do anything for gRPC and HTTP2, right? I saw a lot of articles saying because of fast backoff and things like that. A single TCP connection is worse than multiple TCP connections and all this complicated stuff. Unfortunately, our network is so consistent that we couldn't simulate real network stuff. I know, right? Challenges of working at Google. And so I just kind of ran them all in the same data center. It does take into effect in the next benchmark, but for this one, it did not make any difference. It was just more time. So the first benchmark I did was something that looked like this. I'd take some data, I would send it to a server, and the server would base64 encode that data and then send it back. So, very complicated. Probably don't need an RPC to do this, but it's a very simple benchmark. So what I did is I made 10,000 simultaneous requests. So asynchronously, just spamming out as many requests as possible at the same time, i.e. a very fast for loop. And basically I want to see how fast can the server process them all and send a response back. How fast can we do 10,000 simultaneous round trips? This is when I went down that rabbit hole. We all go down. Oh, wow. All right, I can do better. So 3 endpoints. REST. Non-streaming gRPC. So when you use gRPC, normally you would do a response request. And then there's also the bi-directional streaming gRPC, right? So this keeps a pipe open and just sends packets in that same pipe, kind of. I thought REST would be fast, non-streaming would be faster, and streaming would be the fastest. Pretty reasonable assumption, I think, right? Yeah, okay. So what I did is I made a Node.js server and a Node.js client, and I did this, and I said, people are not going to like Node.js. I like Node.js, but people like, Node.js is async, but it's single-threaded. You're not using the computer to its full potential. But this language called Go, everyone likes Go. It has true multi-threading, right? And then Node.js, uses a C driver for gRPC. So right now it's not a native driver. It calls a C library to do the gRPC, so it has to translate between these different languages, etc., etc. But Go, unlike most other gRPC languages, uses a native Go driver. So Go seems like an interesting choice, so let's do that again. So now I have a Go client and a Node client, and a Go server and a Node server. So yes, I re-implemented both in Go, which is fun. And then benchmarks. Okay, so this is what everyone's waiting for, right? How does it actually work? Oh, thank you, Tableau, for spinning. Don't spin. There we go. So the first thing, no one can see that. Boost it a little bit. Cool. So the first thing is I did the Node.js client and server, and it's exactly what I expected. gRPC streaming was the fastest, non-streaming was a little bit slower, and REST was significantly slower than the gRPC. Okay. When I threw that Go server into the mix, so the client is still Node.js, but the server have a Node server and a Go server. Streaming, very, very similar. Non-streaming, a little bit slower on the Node server. The Go server was a little bit faster, almost as fast as the streaming, in fact. And the REST, again, it was much slower. Go is fast, much faster, but still much slower than the gRPC. Everything seems normal so far. Here's where things got interesting. With the Go client and server, all the times are pretty much the same. In fact, the non-streaming was faster than the bi-directional streaming. Interesting. And REST was just a little bit slower than the bi-directional streaming. And they got me like, why is this happening? I'm not sure. When we add the Node.js server, again, gRPC, very consistent, right? This is the Go client only. And then REST, when I use the Node.js server, it's like, holy crap, that is slow, right? Much slower than the gRPC implementations. But the Go-to-Go is still pretty fast. In fact, it's faster than Node.js. So just both servers and clients, you can see that gRPC streaming is very consistent. It's pretty much the same for all of them. With non-streaming, there's a little bit more variation, but again, pretty consistent. And then REST is just all over the place. So that was very interesting. So going back, so the reason why, and I think I'm right on this, is because Go's HTTP server is HTTP 2. So when Go client talks to a Go server, they're communicating over H2. When the Node client talks to that Go server, it has to fall back to H1, which is why it's going so much slower. And of course, Node right now is all H1 on the default HTTP server. I'm not using anything like Nginx or anything in front of it. It's just a raw no reverse proxy or anything like that. So it's HTTP2 that's actually giving us a huge performance benefit by using a REST as a RPC mechanism. And of course, there's a lot more things you can do with gRPC, but it was very interesting to see that happening. Okay, so then that's one kind of benchmark. That's like asynchronously sending 10,000 requests, kind of simulating real traffic, whatever. It's a benchmark. The second thing I did was a little bit different. I call this one ping-pong. So I send a 1, I send you back 2. I send a 2, I send you back 3, up to 10,000, right? So this is one connection, and we're just going to send ping-pongs back and forth as many times as possible. Now, this is where the 2 data centers versus single data center made a big difference. In the multi-data center scenario, all gRPC, gRPC streaming, REST was basically defined by that big number. So it was like 68.1 seconds, 68.15 seconds, 68.01 seconds. Literally no significant difference. And that's because the network became that important. In the same data center is where so these are all from the same data center, is where the actual interesting results came through. So, again, you have the, sorry, I mixed up the order here, but the non-streaming is the second. Sorry, so flip the yellow and the blue. So, the streaming is the fastest, the non-streaming is the second fastest, and REST is the slowest, the general pattern. But we have these weird things where Go is like way faster than even the streaming. And I was like, what the heck? And I was, because I did my benchmarks wrong, remember I totally had no idea what I'm doing. I was casting ints raw. I wasn't parsing JSON, which turns out parsing JSON does have an overhead. So yeah, if you just take the HTTP response and cast it to an int, it gets pretty fast. Don't do that. But I'll have to redo this when I have time to actually use JSON. But I do expect it to only be somewhat slower than the streaming, probably in line with the gRPC non-streaming. Because again, the network is what really affects this performance. So yeah, 12 server methods, 12 client methods, 2 languages, 3 data centers, all in the sake of science. Yes. So that's great, but what I learned is gRPC is consistently faster, right? It's not always faster than, say, a custom protocol that you design yourself to do something very specific. But what I really liked about it was, even if I used Node.js or if I used Go, and probably any other language, it was consistent, right? So no matter what language I used, and that's important for microservices, of course, I got similar performance, right? Versus REST was like super slow for Node.js and super fast for Go. And so if you're building this like, polyglot microservice dream world where any team can use any language, and then someone picks like Ruby and it's like super slow, and you're like, well, if you just use Java, it'll be faster. That conversation shouldn't happen, right? They shouldn't be limited to what language because of some sort of arbitrary performance that they can't really control. So introducing gRPC into your microservices was the second part that I wanted to look into, because it looks something like this, right? Let's say you have an older application. It's not something you're building from scratch. So you have all these clients talking to your backend with a REST API or just JSON RPC. You updated to version 2, it's still a REST API, and then you're like, I'm going to refactor and use gRPC. And then all your upstream clients, no, I don't want to support gRPC. I want to keep using REST. I'm happy with my performance. Why are you forcing me to upgrade? Right? Forcing clients to upgrade to an old service is our option number 1. The second option doesn't look very nice either. You got to create a REST and a gRPC endpoint for the new service. So it means double the work, right? Unfortunately, I don't think option 1 is a real option. Carrots are better than sticks. You want to encourage people to start using the gRPC endpoint because they want to use it for higher performance, traceability, whatever that gRPC gives you, right? You don't want to be like, no, you can't do this. It's bad. So option 2 is the only realistic option for any sort of reasonable team, right? Unless you have some crazy top-down management. It's like, we love Google, we're going to use gRPC and everything. Yeah, that's weird, but I hope your company's a little bit more flexible than that. So you want to do that, number 2. With Proto 3, the nice thing is that there's a canonical mapping from JSON to Protobuf, right? I think in older versions of Proto, you had to do some weird things and make assumptions, but there's now a canonical mapping between JSON and Protobuf, so you can flip between the two formats very easily. This means that we can build something like a gRPC gateway. So, ta-da, it's open source in gRPC. And it looks like this, right? It's a reverse proxy that sits in front of your gRPC service, and it puts out a REST API. Very simple. How it works, let's pretend that this is our RPC definition. So we have this function called sync person. This is like from my code. This is the base64 thing. And so it takes a person and returns a base64, right? To make it into a REST API using this automatically generated client, we import this like annotations proto, which will define a few things, and we put in this option field. And so obviously this is a very bad REST API design, right? But whatever. So post, when I get a post to /add person, I'm gonna take the whole body and put it in to my RPC. And it'll automatically convert that to the correct protobuf, which is interesting. So this is where things get really, really, really interesting. I thought we put this little proxy in front of our service, and it'll be a little bit slower than REST. Turns out it's sometimes a lot faster than the native REST API. So for Go, yeah, it's a little bit slower, right? Native's here, and the gateway's over there. However, with Node.js, because the Go client can speak H2, and the proxy is written in Go, it's actually faster to put this proxy in front of a gRPC service than have a native REST endpoint. And it holds true for this as well, right? The Node web server is just not fast enough compared to Go web server. So just putting that, even it has to do the translation from JSON to Protobuf, and then send that to the other service that's listening, all that overhead is actually faster. And I did not expect that. That was extremely unexpected. But the data shows it works, so it's real. The bonus is Swagger. How many people here use OpenAPI, Swagger, things like that? Cool. The gateway automatically generates Swagger JSON if you're using that already, so it integrates into your tooling and all that jazz. So takeaways from what I learned: REST isn't dead. There's a lot more that REST does that I didn't talk about. If you're using REST as an RPC framework, that's when you should start taking a look at things like gRPC. If you're actually using all the capabilities of REST API, then maybe you don't want to. But if you're using it as an RPC framework, there's a lot of reasons why it's a bad idea. It works, but there are tools that are built exactly for that, like gRPC. Again, so why? Because gRPC gives you additional capabilities like streaming. Bi-directional streaming is super easy to implement in gRPC. I found that, if you ever use Socket, who's used Socket.io with like Node.js? It was pretty easy to get it up and running web sockets, right? Now think about that for gRPC and like more safe. Sockets are terribly unsafe to use sometimes. They can break and things like that. But because you have all this tooling and stuff with gRPC, it's very easy to implement bidirectional streaming APIs. But the consistency is one thing that I found very interesting. No matter what language I used, I got very similar performance. And the gRPC gateway, easy way to provide backwards compatibility or more compatibility, right? Again, not every language supports gRPC. Basically, every language can hit a REST API. Don't know why this slide is here. It's Kubernetes, it's great. Oh, yeah, okay. You can deploy it on Kubernetes, whatever. The one takeaway, if you can use HTTP2, use it. I don't know if there's a good excuse not to. I think a lot of the talks, I think the talk was by someone from Fastly, one of the CDN companies. Their use case is for people hitting them from the internet. Inside a data center, there's a lot more consistency between your, okay, at least inside a Google Cloud data center, there's a lot more consistency because you're on private fiber, right? You're not competing with the real internet. So the overhead of TCP, a single TCP connection becoming slower and things are not as, they don't happen as often, right? So I think H2 for microservices makes a ton of sense. And thank you very much. If you want to learn more gRPC, everyone knows about it. The gateway's on GitHub. All my Tableau charts are here. I at one point open sourced my code. It looks like a 4-year-old wrote it, so I'm not going to do that right now. But hopefully soon. If you have any questions, please come and talk to me, or you can ask me right now. I also have these really cool beanies that people can get because it's cold. What is with that cold? It's just really too cold. It's California. Yes. Questions?
Can you put these in the Meetup notes?
I can put the slides in the Meetup.
Yeah.
And then the second one is I guess the big problem with gRPC is that you're dealing with external sources like clients or customers. They're not going to have.
Exactly. So that's where the gateway really comes into picture, right? Because like you can't say, hey client, you got to use gRPC also. They're probably going to use REST because that's what they expect APIs to be written in. So if you want to externally expose a gRPC service, in fact, all our Google Cloud services have gRPC and a REST endpoint, and we do something like this. We use a gateway to translate it on the fly. And the performance wasn't that. It was better in a lot of cases, so yeah.
When you install gRPC gateway, have you installed on the same blocks as the actual
Yes. The way I would recommend, this is why this slide was there, was I recommend if you're using something like Kubernetes that has a concept of a pod, I would put them in the same pod. Because you just want them to be scheduled together. Yeah. You could make it as its own service, and then I wouldn't do that. I would just, it's pretty low overhead. It's a very small Go binary. I would just put it into a pod and run it together. Yeah.
How does the client negotiate between gRPC and HTTP?
Yeah. So if you set up TLS correctly, you can actually expose a single port, and the gateway will look at the header, and if it's HTTP 1, it'll go to the REST. If it's H2, it'll pass it through to the gRPC service.
So one of the big things about gRPC is its persistent connections. But if I'm running a load balancer or a reverse proxy,
you get none of those benefits. Yeah. So the proxy will make a persistent connection to the service, but the actual clients that are connecting to proxy will not at all.
In fact, have you tried it at scale and see if that converts you? Because you think
that is one thing I have not tried at scale.
Because if it creates persistent connections to a round robin load balancer, eventually it's going to keep a persistent thing to everything.
What is creating?
Well, imagine you have a load balancer that's round robining, and gRPC is keeping connections alive
to
everybody.
Which sorry, the proxy or the
effectively the proxy is it's keeping connections open to everybody because it talks to everybody as a round robin.
Oh, so that kind of was I was saying to that guy, I would recommend a proxy per process, right? So each server,
I'm combining Linkerd and gRPC.
Okay.
Linkerd is spreading the load all around.
Okay.
And you're keeping the connections open. The connections just stay open because that's what gRPC does.
Yes.
Have you figured out when this breaks?
No, I have not. That's another good thing. Okay, I'm going to try that out. So you're saying you just have gRPC to gRPC, no gateway. Sorry, I think I confused that. Just gRPC services. You have something like Linkerd and Finagle and whatever that's just like
just say Linkerd.
Doing just putting connections everywhere, load balancing them. The gRPC team's answer to that is use client-side load balancer.
But that is a client-side load balancer.
How? It'll pick its connection, and when it drops it, right? So you're saying it's just going to keep the connection open to multiple servers?
I think that's what happens.
I think the connection breaks, and then it'll reconnect. I don't think. Why would it connect to two servers? Why would a client connect to two servers?
If you're intentionally trying to keep things load balanced. I think it was like latency-based scheduling. There's a lot of reasons to spread the load around to all the endpoints.
Right. No, I understand. I'm trying to understand. Maybe I'll connect with you after, but a single client, why would it connect to two different servers?
I'll explain to you after.
Okay.
I mean, a single client is generating lots of load. It will connect to more than one server. If a client has 10 work items, it should be sending it to 10 servers, not one.
Yeah, okay. Thinking.
Depends on the use case.
Yeah, I'll talk to you after. That's really interesting. I want to try this out.
It's like the opposite of session stickiness.
Exactly.
You get it by default.
I think a real good metric might be to use gRPC and REST on Java.
Okay.
A more normal.
If you want to do it, go. Just kidding. I can't, right? My Java is like college Java.
So are your benchmarks in the GitHub?
I don't have a GitHub. I can open source it if people are really interested. Right now it's just Go and Node.js, but it's pretty easy to do this in Java too. If you want, I can open source it.
Replicate your same thing in
Yeah. So why Java? I'm just curious.
there's a lot of Java stack out there, and just
Yeah.
how much of it is Go and how much of it is.
Yeah. Very true.
Do you know how much of it is Protobuf versus gRPC actually?
Yeah. So
HTTP2?
I wanted to try that out. Unfortunately, I couldn't because I just didn't have time. Because the proto parsing, I didn't have big enough. I don't think I had big enough data to actually have a good benchmark. Right, my data packets were maybe like a kilobyte max. So I should have made a lot bigger packets of data. And that I think Protobuf would have been better than JSON. Again, that's just an assumption.
Well, if you're
But
doing REST with Protobuf,
yes,
then you'll get
yes, you will get very similar.
HTTP2.
Yeah, it'll be almost the exact. I mean, so all gRPC is proto over HTTP2 post, right? That's literally all it is. So if you're doing proto over REST, it's what?
And also it's multiplex streaming.
You know, but for the non-streaming, right? It's just that. So you'll get the same performance if you're doing that. But yeah, so I need to do more for the Protobuf side. And people have done that, and they've seen that sometimes JSON is just as fast, sometimes it's slower, sometimes it's faster. I'm not too sure, yeah. Cool, thanks for the questions.